Hi guys, in this first tutorial we're going to be looking at algebraic products, which is basically just multiplying expressions out and collecting up like terms. Now, multiplying out products is actually relatively easy. It's just about practice and knowing your basics. So let's start with our first example. Example 1 is an example that's trying to illustrate basic distribution. Now, what I mean with basic distribution from grade 8 is that if you look at this bracket, there is more than one term in the bracket. Now, if there's more than one term in the bracket, if there is a number or a letter, which in this case is -1/2, directly attached to the bracket, what that means is that -1/2 is multiplied by the bracket. Now, because there's more than one term, it means that this -1/2 needs to be multiplied by each term in the bracket, which is grade 8 distribution. Now, when I do grade 8 distribution, I follow the pattern. I multiply my signs together, my numbers together, and then my letters together, so I never mess anything up. So what I do in my head is I multiply -1/2 by my first term. So I do my signs. Negative times positive, negative. 1/2 times 6, which you can use your calculator for if you don't like fractions, is 3, and my letters, there's only an x squared in that first term. So my answer is -3x squared for when my first term is multiplied by -1/2. Right, then I distribute to my second term, signs. Negative times negative, positive. 1/2 times 8, 4, letters xy. And lastly, -1/2 times positive 12y squared, signs, negative times positive, negative. 1/2 times 12 is 6, and I have a y squared. Now, as soon as you've multiplied out, all we have to check for are there like terms. Now, we've got to remember from grade 8 that like terms mean you have to have exactly the same letter and the same exponent. So x squared is only a like term with other x squareds. xy is only a like term with other things which only have x to the power of 1 and y to the power of 1. And y squareds are only like terms with things which have y squareds. Well, what that means is that there are no like terms in this particular example, and that is as simplified as my expression gets. Let's look at our next example. In our next example, this example is trying to illustrate what we say is a binomial, because there's two terms in this bracket, times a binomial, because there's two terms in that bracket as well. So this is a binomial times a binomial. Now, there's many ways to look at this. One of the ways that I like to look at this is to pretend that that -3 is not there. Now, if that wasn't there, this is a simple case of grade 8 distribution, where my 2x needs to be multiplied by both my terms in the second bracket. Then what I do is say, well, what happens if the 2x wasn't there? Then this would be a case of grade 8 distribution, where the 3 must be multiplied by everything in the bracket. So basically, if I look at this problem as a whole, it's distribution of each of these terms in the first bracket into the second bracket. Now, some people have an acronym to remember what to do when you multiply a binomial times a binomial, and that is FOIL. Now, FOIL stands for multiply your firsts together, multiply your outers together, firsts, outers, multiply your inner two numbers together, inners, and multiply your last numbers together, which is the L for last. So FOIL is just a way to remember exactly what my distribution is telling me to do. I prefer to use my distribution for reasons that I'll show you in a further example. So let's go back now. We are distributing our 2x in. So 2 times 4x would be 8, and x times x will be x squared. And I'm distributing my 2x multiplied by -5. Signs, positive times negative, negative. 2 times 5 is 10, letters x. Then I'm distributing in my +3. Positive times positive, positive. 3 times 4 is 12, letters x. And +3 times -5, letters, signs, positive times negative, negative. 3 times 5, numbers, is 15. And letters, well, there are no letters. Now, From now on in examples, I'm going to do that signs, numbers, letters in my head, but every single time I am following that pattern. Now I just have to check for like terms, and then I'm done. In this case, there are like terms. Negative 10x and 12x are like terms. So I have 8x squared, negative 10x plus 12x. Use your calculator if you do not like integers. Please remember that when you're adding like terms, you don't change the variables. This is 10x and this is 12x, and my answer is x's, not x squareds, or the x's don't disappear, etc. And then I have minus 15. And I'm finished. Right, let's try another one. This example I chose because it's exactly the same thing, but most of us, when we see this in an exam, have a heart attack because there's fractions. It's not that difficult. So I'm going to distribute in my 1 over x, and I'm going to distribute in my 2x. And every single time I'm multiplying, I'm doing signs, numbers, variables in my head. So 1 over x times 2 over x. Well, now I've got to remember how to multiply fractions. In a fraction, I multiply top times top and bottom times bottom. So this is actually relatively easy. Bottom times bottom. So let's look at the top. I've got 1 times 2, 2. And the bottom, I've got x times x, x squared. Done. Not that bad, even though it's a fraction. Right, then I've got top times top is negative 3x. But now it's quite confusing because what's at the bottom? So it might be quite useful for me to remember that these numbers are fractions over 1, because then it's easier for me to think top times top is negative 3x and bottom times bottom would be x. That might be an easier way to do it. Next to 2x times 2 over x, so let's do top times top, would be positive 4x, and bottom times bottom would be x. And our last two would be 2x top times top would be negative 6x squared. Be careful there. It was a positive times a negative, which was negative. It was 2 times 3, which is 6, and x times x, which is x squared. And bottom times bottom would be 1, which leads me to believe that I actually didn't even need to write that 1 in that case. Now this is more complicated to simplify, but as soon as I wrote down this fraction here, I was thinking, oh, but my x's can simplify. X goes into itself once, and x goes into itself once. So if I simplify those two fractions before I look for like terms, I have minus 3, I have plus 4, and do I really need to divide by 1? Any number divided by 1 is itself. So finally, I can figure out my like terms, which would be the minus 3 plus 4, which would be positive 1, minus 6x squared. Just note that these 2 over x squareds and this minus 6x squared are not like terms, because in this case your x squared is at the bottom, and in this case your x squared at the top. So that is my answer. So in an exam, don't be intimidated by fractions. They really are quite easy, as long as you remember when you multiply fractions, you multiply top times top and bottom times bottom. Right, let's go on to the next one. Now this is an example to illustrate why I like to not think of FOIL necessarily, but to think about what multiplication means. This means that if I ignore my positive b, this means I need to distribute in my 2a because it's multiplied by my bracket. But on the other hand, if I ignore my 2a, this means that I need to distribute in my b. Now FOIL doesn't apply here because it's not a binomial times a binomial, which is why I always prefer to think of this as you distribute in your 2a and you distribute in your b, and then you don't need things like FOIL. So let's go. 2a times a squared would be 2a cubed. Let's just do a quick recap of exponents. When I multiply powers of the same base, the a and the a, I add exponents, so it's 1 plus 2, which is 3. 2a times negative 4ab would be negative 8. A times a squared, b. Each time I'm doing signs, numbers, letters. 2a times positive 3b squared would be positive 6ab squared. Now to do the b times a squared. Now this would be a good time to realize that I can write this as ba squared, but because this means b times a squared, and multiplication is called commutative. It's a property of multiplication. In multiplication, it doesn't matter which way around you multiply. So I could write this as a times b squared. Now, when I multiply out, I always write things alphabetically because it will allow me to see if there's a like term. If I don't write alphabetically, often I don't think that there's a like term. So in my head, I'm going, oh, b times a squared, but I always write that as a squared b. It helps me with my like terms. Right, then b times negative 4ab would be negative 4ab squared, alphabetical, and b times 3b squared would be 3b cubed. Great. Now all I've got to do is my like terms, and then I'm done. Right, let's have a look. A cubes. Any other a cubes? Nope. So that's a cubed. A squared b's. Any other a squared b's? Yep. There's an a squared b. So negative 8 plus 1 would be negative 7a squared b. Next, 6ab squared. There we go. There's some more ab squared. So that's plus 2ab squared. And then 3b cubes all by itself. Just remember, when you're adding like terms, you do not change the variables and their exponents. That's only for multiplication and division. So basically, that is just a case of distribution as well. Right, now what I did for this one is just simply swap it around. Again, people don't like it when there's a trinomial, 3 terms, times a binomial, because they suddenly get confused because it's not the same pattern. But if we just remember that this is simply distribute your 2a, distribute your b, and distribute your minus 1, it's actually pretty simple. So let's go. Let's distribute out 2a. 2a times a squared, 2a cubed. 2a times b squared, 2ab squared. B times a squared, writing alphabetically, a squared b. B times b squared, b cubed. And lastly, minus 1 times a squared will be minus a squared, and minus 1 times b squared minus b squared. So it's simply distribution. I can quickly add up my like terms. There's 2a cubed, ab squareds. Any other ab squareds? Nope. 2ab squareds. A squared b's. Oh, I should actually stop immediately. There are no like terms, which maybe I should have checked before I launched off, because I might waste time in an exam. But let me check. A cubes? No other a cubes. A squared b's, ab squareds, b cubed, a squareds, b squareds. Nope, there are absolutely no like terms in this example. So I'm done. Now what I would do if I was you is stop the video now, write down exercise 1 and practice these simple distributions. They're simply either a monomial times a bracket, or a binomial times a bracket, or in some cases trinomials times a bracket. But practice your simple distributions now.